Josiah Willard Gibbs was the quiet revolutionary who mapped the invisible laws of the universe. While his life was unassuming, his legacy is the cornerstone of modern engineering and chemistry. By mastering the equation on this blueprint, we transition from guesswork to precision. This formula doesn't just describe energy, it predicts spontaneity and efficiency, allowing us to determine if a reaction will occur before even entering the lab. Understanding Gibbs' work empowers us to optimize industrial processes, develop new materials, and harness the very drivers of cosmic entropy. We aren't just studying history, we are wielding the fundamental toolkit for innovation. Let's explore how these blueprints continue to build our future. True genius often operates in the shadows. Despite being hailed by Einstein as America's greatest mind, Gibbs remained virtually unknown, working without pay for nearly a decade. This underscores a vital outcome for us. Groundbreaking innovation doesn't require a global stage. It requires depth. By valuing substance over celebrity, Gibbs built a theoretical framework that still drives modern thermodynamics. His story proves that concentrated, dedicated focus, regardless of public recognition, yields the most enduring results. Understanding his quiet discipline allows us to appreciate that the most influential solutions often come from the most unexpected, unassuming sources. Let's look at how his unpaid years changed the world. Gibbs' physical world was incredibly small, centered on a few blocks in New Haven. Yet, from this tiny epicenter, he launched ideas that now span the globe and reach the lunar surface. This map demonstrates that intellectual reach is not limited by geography. By mastering fundamental laws from a single laboratory, Gibbs provided the scaffolding for the global chemical industry and the digital architecture of modern AI. For us, the benefit is clear. Depth of thought creates universal utility. His work proves that local focus can drive global transformation, fueling every technological leap from industrial manufacturing to the information age. We aren't just looking at a life, we are looking at the origin point of the modern world. Gibbs' journey began not with abstract theory, but with the practical grit of train mechanics. By earning the first American PhD in engineering, he set a new standard for domestic intellectual rigor. The outcome of his 9-year unpaid tenure at Yale reveals a crucial truth. Intrinsic value often precedes market recognition. Gibbs didn't work for a paycheck, he worked for discovery. This dedication provided him the freedom to develop theories that would later prove indispensable to global industry. When Johns Hopkins finally validated his worth with a recruitment offer, it wasn't just a salary negotiation. It was a recognition of the immense competitive advantage his genius provided. His path teaches us that foundational expertise is the ultimate leverage. Gibbs achieved the impossible. He visualized the invisible architecture of energy. By publishing his masterpiece in a local journal, he prioritized scientific integrity over fame. The outcome was a framework so advanced that only James Clerk Maxwell fully grasped its power, physically molding a model to prove its validity. This breakthrough provides us with the definitive rules of chemical equilibrium. By moving beyond text into 3D conceptual space, Gibbs gave us the tools to map complex physical states with total certainty. His legacy ensures that today's engineers can design systems with perfect efficiency, confident that they are following the universal laws of the cosmos. True authority doesn't need a loud platform, it needs an undeniable truth. This single equation birthed the modern chemical industry by predicting the impossible. By weighing the pull of energy against the pull of chaos, Gibbs gave us a definitive metric for spontaneity. When delta G is negative, a reaction happens on its own, providing us with the power to engineer materials and fuels with total foresight. This isn't just theory, it's the fundamental tool that allows us to distinguish between what is physically achievable and what is merely a drain on resources. By mastering this balance, we gain the ultimate outcome, the ability to harness the laws of thermodynamics to drive human innovation forward with mathematical certainty. Gibbs didn't just use mathematics, he reinvented it to fit the physical world. By abandoning the clunky old way of quaternions, he developed the streamlined language of vectors we use today. The outcome was a paradigm shift in engineering. By separating math into scalar and 3D vector terms, Gibbs provided the essential tools for mastering fluid mechanics and electrodynamics. This wasn't merely a theoretical upgrade, it was the invention of a practical directional toolkit that allows us to navigate and build in three-dimensional space with unprecedented precision. Because Gibbs chose elegance over complexity, he laid the mathematical tracks for nearly every modern technological advancement, from aeronautics to global communications. Gibbs fundamentally changed how we perceive reality. Before him, science tried to track every individual atom like a deterministic billiard ball, a physical impossibility. By coining statistical mechanics, Gibbs provided a monumental outcome, the ability to master complex systems through the power of probability. His canonical ensemble allows us to predict the behavior of entire populations of atoms with staggering accuracy. This shift empowers us to engineer semiconductors, understand biological processes, and develop modern materials without needing to see every moving part. Gibbs proved that when we embrace the statistical nature of the universe, we gain the ultimate control over it. We moved from tracking individuals to managing the cosmos. Gibbs was the architect of every scale, providing a unified toolkit for the entire physical world. By bridging the gap between visible matter and invisible atoms, he gave us the power to master complexity from steam engines to semiconductors. The outcome for modern science is a total command of reality. We use his thermodynamics to map phase changes, his vector calculus to navigate electromagnetic forces, and his statistical mechanics to predict atomic chaos. This multi-scale mastery ensures that whether we are designing global industrial systems or nanoscopic circuitry, we operate with absolute precision. Gibbs didn't just study the cosmos, he gave us the blueprints to build it. Josiah Willard Gibbs was the silent architect of our modern world. While he lived quietly, his intellectual output formed the invisible foundation upon which all 20th century physics was built. The outcome of his genius is nothing less than the framework of our current reality. Without his pillars of free energy, vector products, and statistical probability, we would lack the tools for relativity, quantum mechanics, and the information age. By mastering the fundamentals so thoroughly, Gibbs allowed giants like Einstein and Planck to reach further. His legacy proves that the most stable structures are built on profound, quiet depth. We owe our entire technological landscape to a man who lived a few blocks from his lab, but thought across the dimensions of the cosmos. Josiah Willard Gibbs may have lived a quiet life, but the universe refuses to forget his name. His legacy has transcended the walls of Yale, to be etched into the very stars he helped us understand. By naming craters, asteroids, and research vessels after him, the scientific community acknowledges a fundamental outcome. Gibbs didn't just contribute to science, he defined its future. Today, the Willard Gibbs Award remains a beacon of excellence, honoring those who continue his tradition of profound discovery. For us, his story is the ultimate proof that true brilliance eventually reaches every corner of the cosmos. His name remains a permanent fixture of human achievement, guiding every new generation of innovators who look toward the horizon. Scientific greatness is often equated with ego, but Gibbs proved that the most profound insights come from the most unassuming minds. Described as genial and devoid of personal ambition, he focused entirely on the work rather than the acclaim. The outcome of this unselfish approach was a career that mapped entirely new scientific continents, without the distraction of self-exaltation. For us, his life serves as a masterclass in professional integrity, showing that true influence is built on the substance of one's contribution. By valuing the beauty of a dignified life as much as his equations, Gibbs reached the far horizons of the unknown. He leaves us with a legacy where character and genius are perfectly balanced.